Welcome to another of our training sessions for the OzSTAR HPC environment. In this session, we're going to cover a general overview of what's available within the environment and then go through how you can get started if you're not already familiar with that. So yeah, just a quick rundown. So we have two supercomputers now available within this environment. We have the OzSTAR machine, which has been running happily since 2018 and hopefully all going well, will keep going for many years ahead. And we now have our new Ngagu Tinderbeek machine, which was installed early in 2023. And the plan is for us to run both of those in parallel, for much of the remainder of this decade. So OzSTAR, just as a reminder, has 117 compute nodes. The compute cores are Intel Skylake. There's about 4,200 of those in total, 36 per node. Each standard compute node has 192 gigabytes of RAM, and as well as the 36 compute cores contains two NVIDIA GPUs, P100 GPUs in all but two of the nodes, which have V100 GPUs. And 8 of those 117 nodes have a greater amount of memory, 384 or 768 gig of RAM in those 8 nodes for more data-intensive applications. For the new machine, Ngagu Tinderbeek, there are 182 compute nodes. The compute cores are now AMD Milan, still the same x86 architecture, so you shouldn't have any problem porting code from one machine to the other. But it's a different environment, newer hardware, different flavor of CPUs. So it's always recommended that you recompile your code when you switch from one hardware environment to another. So if you want to make sure it's fully optimized, that is recommended. The 182 compute nodes are comprised of 150 standard nodes, which each have 64 of these AMD Milan compute cores, 256 gigabytes of RAM. They have a 2 terabyte NVMe or SSD flash drive in them for rapid local I/O. So that can be something people might want to target for their jobs. We then have 10 high memory nodes in this system that have a terabyte of RAM each. And so those 150 standard nodes and those 10 high memory nodes are just compute, like standard compute CPUs only, no GPUs. And then we have 22 data accelerator nodes that each have the same CPUs, so 64 AMD Milan cores, the 256 gig of RAM, but 4 NVIDIA A100 80 gig GPUs each. So those are definitely what you want to target if you're a GPU enthusiast. The network internal to OzSTAR is a 100 gigabit per second network. For Ngagu Tinderbeek, it's faster, 200 gigabit. And they're both networked through to the same Lustre file system, which are currently expanding the capacity of that and will be 16 petabyte capacity shortly. So both machines see the same file system and you can navigate around freely within that environment. We'll get on to accounts and where to run jobs and so on in a minute, but just want to highlight that it's the same accounts and project system for both machines. Nothing's different there. They both see the same file system, same home directories, same project directories. They both use Sloan for the job scheduler, and they both have modules for the software stack. But right now, as we speak, the machines do have different operating systems. So the software stacks are a bit different from one to the other, although that will be changing by the end of September 2023 when we upgrade the operating system on OzSTAR to match that of Ngagu Tinderbeek. All right, so if you haven't accessed our system before, you will obviously need an account, and you also need to be a member of a project in order to be able to use the system fully. So access to both of these is managed through our accounts portal, which is at supercomputing.swin.edu.au/account-management. So you can go there and go through a two-step process where you first apply for an account, wait for that to be approved. And then once that's done, you'll need to join a project. Well, you'll need to either join a project or submit a request to create a project. If you're a student, you will need to join a project. We need staff members to create projects. So yeah, if there's not already a project that you've identified to join, then you will need to ask, presumably your PhD supervisor, to also get on the system and request a new project to be created. Once you have an account in a project, you can then access the system. And yeah, encourage everybody, new account holders and existing account holders, to make ongoing use of this accounts portal to make sure that you keep your contact details up to date, and also if any other details change, such as you change institution, to update that as well. It's important that we can always contact you. If we identify, for example, that you have jobs running that aren't working well, we will contact you to discuss those. And if we can't, then we will need to suspend the jobs and potentially suspend access until we hear from you. Also, I need to stress, but hopefully it's obvious to everybody already, that you shouldn't share your account information with anybody. It's one account per individual. Okay, once you have your account, you're ready to access the system. Each machine has 2 head nodes, so you can simply choose to go in via OzSTAR or Ngagu Tinderbeek by SSHing to your username at ozstar.swin.edu.au or SSH your username at nt.swin.edu.au. If you go in via OzSTAR, you will get assigned randomly to either the Whānako 1 or Whānako 2 head node. You can instead access those directly, so just replace OzSTAR in that command there with either Whānako 1 or Whānako 2, or if you prefer, just use the abbreviations F1 or F2. Similarly for NT, if you go in through there, you'll be onto the Tuarana 1 or Tuarana 2 head nodes, which can also be referenced as T1 or T2 for shorthand. The file system is a 2-phase file system. You have a home directory, which will be /home/your username. For everybody, that is restricted to 10 gigabytes and 100,000 files maximum. That's non-negotiable because we do back up the home directories and we have a lot of accounts, so we need to keep the total size manageable. So it's recommended that this is where you would keep your source files and anything that would be catastrophic for you to lose, but don't keep large amounts of data there, particularly data that is easily reproducible in the case of a catastrophe. And your project directory, which we referenced as /fred/oz, whatever number the reference number is for your project. So when you join a project, everyone in that project has access to that project directory. And then it's sort of up to the project group to determine how they manage that. But typically, as a new user, you would go there and then create a subdirectory that matches your username. And then within that, it's where you would store your files for that project. But be aware that everyone within the project can fully access the project directory. It's a shared space. When these are created, they're given a default 10 terabytes and 1 million inodes per project. If necessary, that can be expanded, but definitely we're keen for everybody to keep their project and home directories as cleaned up as possible. Make sure you clean up after yourself, delete files that you don't need, and manage your data responsibly. Project directories are not backed up, but they are designed to be fault tolerant. So it would need quite catastrophic sequence of disk failures for us to lose data, but it's not out of the question. So make sure that if you've got data there that you really need, try and find an alternative location to back that up. It is certainly the place where we suggest you store big data and you direct your simulation output into your project directory and so on. I mentioned inodes there, so stay aware of inode usage. That inode is basically the number of files. So there is a quota on that. You can check your quota in terms of raw data and inode quota at any time by just running the quota command. And if you say you got a lot of small files and they're in a directory that you're not going to access for a while, then it's a good idea to tar that up so you turn many files into a single file. And also, just on the side, there's no need to worry about compressing data using gzip or anything like that, because the ZFS ZFS file system that is part of our OzSTAR setup takes care of inbuilt compression for you. So where to run jobs once you access the system? Well, you can run test jobs on any of the head nodes. So that's where you would compile your code, run some short test jobs, make sure everything's working well. But you shouldn't get in the habit of doing all your work on the head nodes. They need to be primarily access points for everybody to get into the system. And as such, we have CPU and memory limits on them. So even if you did try and run a larger job on those nodes, you'll find that you can't, because we need to make sure that they stay available to everybody. Can't have somebody hogging all the memory on one of the nodes, for example. So the main place to do your work is by accessing compute nodes through the batch queue, also known as the job scheduler. And so that's what we refer to as Slurm. So you submit your script to Slurm, requesting the resources that you need. And if you want to run your job on OzSTAR compute nodes, you just make sure you submit your job from one of the OzSTAR head nodes, so from Farnacle 1 or Farnacle 2. And if you want your job to go onto the Ngagu Tinderbeak compute nodes, then similarly you submit your job from one of the head nodes on that system, from Tuarana 1 or Tuarana 2. You can also launch an interactive session through Slurm, where you get an Xterm directly on a compute node and then can operate from the command line. That's all I'm going to cover in this introduction, but I definitely want to reinforce that everything that I've mentioned here, plus a lot more, is written down in our user documentation, which you can find at supercomputing.swin.edu.au/docs. So please take a look at that. There's a lot of extra information there on using Slurm, on the software modules, and everything else that we can think of that you might need to know. If after taking a look at that, you're still unsure of anything, then please ask us for help. And you can do that anytime through our ticketing system. Just send an email to hpc-support@swin.edu.au. And there again, I've got the address for managing your account and or requesting an account if you don't have one already. So that gives you all the information you should need to get onto our system and make good use of OzSTAR. So I wish you all the best in doing that and look forward to seeing your jobs running.